त्याला शेअर करू.
Dear participant, just wait for 5 minutes.
Okay, sir.
Session expert will join to the meet.
Dear participants, today we uploaded the attendance for the first day. So meanwhile, you go through the Atal portal, see, do the login and check whether your attendance is there or not. If any difficulty or any doubt, you can contact. So we will update that thing. And regarding the attendance for certification, we require minimum 80% attendance. So we are having the online tracking on the Google Meet. So keep login during the session. Also, we provided the one feedback link for day one. So it's request to all the participants, please go through that link and give your valuable feedback. So we will update that thing in our upcoming days.
Yes, sir.
Good evening, everybody.
Very good evening, sir.
Good evening, sir.
Very good evening, sir. Sir, just before I start the session, just I'll take a 5 minutes to introduce, sir. Uh, Dear participants, now it is time to move for the next session, which is on the clean energy for the automobiles. So we have the today's eminent speaker, Dr. Kumar Jain, sir. Uh, Currently, sir is working as a professor in the Department of Mechanical Engineering at National Institute of Technology, Karnataka, Surathkal. Uh, Sir is having the research areas of alternative fuels of IC engines, simulations of IC engines, heat transfer, and also they are working in a different heat transfer field also. Sir has pursued his PhD in the field of hydrogen fuel spark plug ignition from the IIT Delhi in 2011. I am Tech from KREC Surathkal. Currently, it is NITK Surathkal in a branch of heat power. B from Bangalore University in mechanical engineering. Sir is having more than 60 plus national and international journal papers. Also, he is contributing the different number of chapters in the books. He totally is having the around more than 4 chapters in a different books, and in a conference he has published more than 40 plus journals, and in an international conference more than 25 plus. Also, sir is having the more experience regarding this clean energy for the automobile, and he has guided more than 10 students for the PhD, and MTech by research more than 10 students, and only the MTech students more than 25 students. Sir is a lifetime membership for the different bodies like a Combustion Institute, and he was the BOE member at UVC Bangalore. He was the co-chair during the national conference in 2010, which is held in NIT Surathkal. Also, he was the member of the BOS at the different institutes, as well as it is in a government as well as very different private universities. And sir has delivered more than 50 guest lectures, which are invited overall throughout the nation. If I speak about the whatever the achievement of Dr. Kumar Jian, it is very long way. So I stop here with a short introduction. Sir, thank you, sir. I welcome you for this FDP, sir, which is sponsored by the Atal AICT, sir.
Yeah, thank you, brother. Uh, can you see the slide?
Yes, sir.
Just the screen I just am sharing.
Yes, sir. It is full screen only.
Now it is visible, no?
Yes, sir. It is visible, sir.
Yes, sir. Yes, sir. Visible, sir.
No.
It's okay?
Yes, sir.
Yeah. Good evening, everyone. Actually, even my student is also there. My friend Chitragar. Good evening, Chitragar.
Good evening, sir, and welcome to this
Good
platform,
evening.
sir.
Yeah,
Very
thank
happy
you.
to see you come, sir.
After a long time, yes.
Yes, sir.
Yeah. Dear friends, just I would like to give some introduction to the IC engine because nowadays the electric vehicles are also competing with IC engines, and why this green energy is very very important. Just I'm going to highlight with my presentation. Maybe if you have any queries at the end, I'll take the queries and just, I mean, fuel, it's not a new concept. It is maybe 150 years of history is there, but still there is a lot of research is going on related to the ICE engine. Not only changing the design of the ICE engine, or even they are working on fuel also, because even by changing the fuel or cleaning the fuel, so we can reduce the emissions which is produced by the combustion. Okay, so the combustion is a very, very important thing in the IC engine. Already, in as a mechanical engineer or even any energy engineer, the thermodynamics I have studied, and we know that thermal efficiency is a very, very important parameter. That is in combustion. Generally, the thermal efficiency is a very important parameter. By by that number, we can say whether the combustion is good or not, or the device is good or not. For example, generally, whenever we buy a vehicle, the first thing what we see is what is the mileage it can give. So, but in laboratory level, generally we measure with specific fuel consumption. That is how much fuel is consumed for producing 1 kilowatt. So the combustion is very, very important process in IC engine, where the chemical energy will be converted into heat energy and then mechanical energy, that is within the IC engine. So it is a exothermic chemical reaction where fuel and air burnt and product will be released, plus heat will be released. So for us, the how much heat is released is a very important thing. So everybody, even after the latest technology, so the thermal efficiency is nearly 35 to 40%. We cannot I mean, we are still there is a long way to go, because when we have seen Carnot cycle, so the thermal efficiency crosses 65 to 7%. That is even after considering so many assumptions. So what I want to say is, when ICE engine started, that time the thermal efficiency was very less, but now it is improved up to 35 to 40%. It means that we are saving a lot of fuel by improving the thermal efficiency, or redesigning the engine, or changing the quality of the fuel. Okay. So, ignition. So when we design any IC engine, we have to provide a proper fuel and proper air. Then only the combustion will be stable and proper emissions will come, and with the right quantity of heat will be liberated. So even if you make it a rich mixture, that is a very, I mean, more fuel concentration, or more oxygen concentration, that is a lean mixture, the combustion will not be stable. Okay. To make stable, we have to operate with a limited fuel air mixture. So, for example, in a petrol engine, generally it will be 14.5 kg of air required for burning of 1 kg of fuel. So maybe a little bit, that is near to stoichiometric condition, we can operate the engine. But if you go beyond some limit, maybe if you keep it in mind that it should burn properly, because in IC engine we need more power in a given time, that is in milliseconds. So the combustion should be fast. I mean, the property of the fuel is very, very important thing. That is one thing you have to keep it in mind. So the basic concept, everybody know this. It's not a new concept. So our IC engine, just like we work as a war cannon. So in a cannon, what happens? We keep some gunpowder and we ignite. So in front of that iron ball will be there. So as soon as we ignite, the gunpowder will burn and it will try to expand. That is explode. So due to that, high pressure wave will be released and it strikes the that iron ball. That is, it hits the iron ball and the iron ball is moving. Same concept we can analyze in IC engine. So in IC engine, cylinder will be there, and inside the cylinder, piston. So the piston movement is based on the combustion of the fuel. So as I said, the combustion will take place in a milliseconds. that much fast combustion should take place. So because every cycle maybe 1500 1500 rpm, or whether if you take a racing car maybe 20,000 rpm. So in a four-stroke engine, yeah, I mean the combustion should be in terms of milliseconds. Okay, so even cycle, but duration of the combustion also still it is less. Okay, so based on this combustion, the ICE engine basic process are there. Just if you have any queries, please keep it in mind, and at the end you can ask me. So there are different types of IC engine, including the petrol engine, that is a constant volume combustion engines, constant pressure combustion engine, and etc. That is in which process the combustion happens and how heat is added is a very important thing. So a few concept, that is the petrol engine works on auto cycle and diesel engine works on diesel cycle. So based on the fuel property, we are choosing the engine. Even nowadays, research is happening related to the alternative fuel. For with respect to the spark ignition engine, maybe we can choose LPG gas or CNG gas, or including a hydrogen. That today what I'm going to present. Okay. And with respect to the diesel, even nowadays, the government of India is talking about biodiesel or some other alternative fuel. Right? Generally, it is a biodiesel, and even ethanol also is used as an alternative fuel for the ICE engine. So, with respect to engine design, as I said, we can improve the thermal efficiency in two ways. One is by redesigning the engine, that is, the component of the engine can be redesigned so that the combustion will be good, and whatever the power is produced within the cylinder, it will be transferred to the at the end. Okay, maybe it is available in the shaft, crankshaft. Okay, so with respect to the section stroke, and already we know, the latest technology. So even they are trying to replace the valve with a solenoid valves. Okay, that is a when you see this mechanical operated valves with a solenoid valve, so that the we can avoid the pumping losses, and we can improve the even volumetric efficiency also. So with respect, each stroke, a lot of research is happening and new technologies are introduced. Instead of natural aspiration, we have moved to the supercharger or turbocharger, so that we can pump the more air. Okay. So when we pump more air, we can pump more fuel, we can burn. After burning, more heat will be released, and that we can convert into power. It means that for a given volume, we will get the more power output by adopting a supercharger or turbocharger. Okay, that is a thing happening. Next, steam injection. Just already, we know the many governments, not only in India, most of the European countries or American countries, so they are working towards reduction of emission. That is, today's topic is how to reduce the emission and how to improve the thermal efficiency of the engine. So they're trying to reduce the maybe emission by injecting steam or nowadays, exhaust, and I'll come back to you. So we are using different reactors after combustion. So there is one, and as I said, they are changing the valve mechanism. So including instead of two valves, nowadays they are increasing four valve mechanism, so that the volumetric efficiency is improved, and even the pre-ignition problems can be avoided in multi-valve aspiration system. Okay, IVTech and all new technologies are still there on under laboratory conditions, so it will come. And with respect to the fuel injection or air injection, so instead of carburetor, we have moved to the direct injection system. Even nowadays, the most of the vehicles, that is with respect to the spark ignition engine, coming with a GDI system, that is gasoline direct injection system. That is a new technology, and still there is a lot of scope for this. So with respect to the carburetor, the thermal efficiency was very less, and when we have moved to the injection system, that is inlet manifold or cold fuel injection, the thermal efficiency is increased very much. So now, after introducing direct injection system, the thermal efficiency has come down. Increased to 35 to 40% now. Okay. And with respect to the compression stroke, there is a variable compression ratio is there. Even the running vehicle. So whenever we require change in the compression issue, we can do, or even D cylinder. We can cut off the combustion in multi-cylinder engine by operating with only one. So that is our new technology has come in, and the direct, as I said, gasoline direct injection system (GDI) system is already introduced, and most of the vehicles are coming with this technology. Okay, and already the ignition. A lot of research is happening, and nowadays digital electronic ignition system is there. So in the digital electronic system, it gives the minimum ignition energy and the timing, because there is no misspark or this one. Even if you take a multi-cylinder engine or a single cylinder engine, that heat addition, because when you have seen the first slide, fuel plus air, if you two reactants are there, the combustion won't initiated. It requires some minimum ignition energy. That minimum ignition energy we can move from magneto system to the digital electronic system. But the latest technology, or at a laboratory level, is a laser ignition system. So still the people are working on that. It is not implemented in public vehicle, but in the presently digital electronics ignition system have been introduced. That is just like sorry. This is the old system. Just a minute. Okay, this is the old system, and new systems are coming in. In the exhaust stroke and manifold. So even as I said, by introducing a supercharger or turbocharger, we can improve the power output. So that's one aspect. The second one is the catalytic converter, so that we can reduce the emissions, including whether it may be a carbon monoxide, unburnt hydrocarbon, or including nitrogen. So nowadays we are using SCR catalyst, selective catalyst reactor, so that NOx emission can be reduced. Okay, so a lot of research is happening. These are individual topics. Actually, I'm not covering these things. I'll be focusing on hydrogen. So as I said, why alternative fuel and what are the benefit to the country? So maybe every day nowadays you might have seen the e-vehicles are coming, electric vehicles. They are quoting that it is a zero emission vehicles. Okay, but if you look into basic things, actually it's not a zero emission vehicle, that is a e-vehicle, because it requires electricity, and electricity we are producing using fossil fuels, maybe coal or diesel, or so when we burn coal, again carbon monoxide or carbon dioxide will be released to the atmosphere, not in urban area, but that is wherever we are using electricity. But some other places we are using coal or fossil fuels, we are burning, and we are producing carbon dioxide and carbon monoxide, or harmful emission, and we are adding to the atmosphere. That is, total emission will be same whether you use them. But only thing is, when we produce electricity is far from place, that is maybe 1,000 kilometers away from the urban city. So when we supply current from one place to another place, there will be loss of electricity. That is, if you produce electricity at in some 1,000 kilometer and supply to the rural area, maybe only one unit will be available and one unit will be lost. That is, out of 2 units, 1 unit will be lost and 1 unit will be used. So the lot of emission will be added. So what I want to say is the e-vehicles, the electricity, if you produce from fossil fuel, then we cannot say it's a zero emission vehicles. Yes, if you produce electricity from solar energy or wind energy, that is a renewable energy, then we can say it's a a zero emission free vehicle. But presently in Indian context, we are mainly depending on the fossil fuel. There is a coal-based power plants and other one. So e-vehicle is a competitor for the IC engine. But IC engine, as I said, it has got its own advantages and disadvantages. Even yeah, maybe in future, e-vehicle, a fuel cell comes, maybe the IC engine will may go because the fuel cells are having a very good thermal efficiency. Anyway, I'm going to tell the technology in next slides, coming slides. So just I'll skip this part. That is a combustion SI engine. Yes, this is a very important slide. Why means nowadays we talk about alternative fuel. So even when you simple thing, there is a biodiesel. So when we produce biodiesel from the vegetable oil or any oil, there will be, the property should match with the diesel. Similar way, when we choose a spark ignition engine, the alternative fuel properties should match with the gasoline because we have experienced with gasoline and we know when we put gasoline in any fuel ratio, what will be the combustion, what are the emissions, what will be the thermal efficiency, we know. Okay, so when we take CNG gas or hydrogen gas, hydrogen gas, you can see the properties. So it is near, and sometimes some properties are favorable with respect to the IC engine, SI engine, and some properties are not favorable. But only thing is nowadays the sensors are available, electronic controllers are available. Using sensors and actuators or electronic control unit, we can control the combustion in better manner, and even we can improve the thermal efficiency of the spark ignition engine or compression ignition engine. Okay, these are the few properties. Okay, very important properties. But difference you can observe when petrol and oxygen, that is a petrol gasoline or 7 to 4, that is a flammable limit. But whereas CNG is 0.4 to 1. Hydrogen to CNG, but hydrogen it comes up to 0.1 and it can go up to 7.1. What I want to say, it will burn with a lean mixture or even with a rich mixture. That is the advantage of hydrogen gas. So the combustion will be stable, maybe after 0.4 equivalence ratio, and it gives the better thermal efficiency because of burning velocity. Even the burning velocity, you can observe it is 0.37 meter per second and here 1.85 meter per second. Now, what I want to say, once the combustion starts, there is a flame will travel with this speed. And if you refer hydrogen, it is 10 times faster than gasoline or CNG. So the whatever fuel is burned, finally, it improves the thermal efficiency of the engine. That is the advantage of hydrogen. And the C10 number, octane number, you can observe it is increasing in order and it gives better sun compared to the petrol. So that's why generally the hydrogen is preferred in gasoline, and without changing, with minor modification, we can use hydrogen in a spark ignition engine. So the adiabatic flame temperatures already, theoretically the combustion temperature will be around 2500, and here nearly same temperatures in terms of Kelvin. Auto ignition temperatures are nearly same. Okay, that is based on again fuel ratio. If you go for lean mixture, then minimum ignition energy we may have to change. Here you can observe in terms of millijoules. So 0.24 millijoules, and this one is so okay 0.02. So what I want to say is some properties are advantage and some properties are disadvantage. Similar way, whenever we take any additives with the gasoline, just improving the velocity or improving the CT number, the sometime maybe the density will increase or the combustion may not be proper. So fine, but while choosing any fuel, we have to see that proper combustion so that the thermal efficiency will be improved and emissions will be less. So these are the things we have studied in ICE engines. So the effect, that is a flame speed, is mainly depends on this. So with respect to the spark ignition engine, maybe fuel ratio is a very important thing. Whether you work, petrol means, as I said, it is we operate with a equivalence ratio, that is a 0.9 to 1.1, and engine size also varies. If you go for bigger size engine, sometimes we go for multi-spark ignition. Uh, Ratio again engine, that is homogeneous gas combustion ignition engine. So where we can use petrol, diesel, but again it's under laboratory condition. So, but with respect to the fuel, we can change the compression ratio so that we can optimize with respect to the size or fuel ratio. Okay, and based on the application also. So you can observe in spark ignition engine, the swirl is a very, very important thing. That is, whenever we design a piston cylinder, so we have to see that the turbulence should be there so that homogeneous mixture will be created. If too much of turbulence is there, then again it is a disadvantage with respect to the spark ignition engine. And here there is no swirl, I mean normal swirl, high swirl. Okay. Only thing is the spark plug is mounted on the cylinder wall. So the spark is coming after 5 degree, 10 degree crank angle. You can observe the flame front is gradually moving towards the unburnt mixture. Okay, here. So after 25-degree crank angle, the burning takes place only off. Okay, the remaining you have to give more time. But when you take a swirl, that is if the homogeneous mixture will be created, so same timing. So if spark is coming, the flame front will be developed and moving towards the unburned mixture. It is very fast compared to the no swirl. But okay, and if ice swirl is there, you can observe the combustion will be very fast. That is, ice swirl means with respect to spark, we have to see that the swirl should be other side. If movement of the air more near to the spark plug means sometimes the spark it won't give minimum ignition energy. So what I want to say is the turbulence should be there, and so that the complete combustion happens here. So next, if instead of mounting spark plug on the cylinder wall, if you mount on the cylinder head and spark is produced at the center of the cylinder, you can observe here. So in two cases, no swirl here. Okay, and only thing is here two spark plugs are there opposite side and only center. But you can observe within 20, I mean maybe 20 second, I mean 20-degree crank angle, the fuel will be completely burned. Okay, and even when you take two spark plugs, the fuel will be burnt very fast compared to no swirl or this one. Okay, so what I want to say is whenever we design a combustion chamber, IC engine, so the cylinder is very important thing. Cylinder head is important. Piston is important. Even the fuel injection system, ignition systems are very important with respect to the spark ignition engine. And with respect to the CI engine, diesel engine, again, fuel supply system at what pressure? Because nowadays we have introduced high pressure injection, that is a CRDI engine. So, new technology is there, so we can adopt and we can see that better combustion, less emission. Okay. So this is a normal brake specific fuel consumption. The trend will remain same when you increase the compression ratio. The brake specific fuel consumption, that is a fuel consumed for producing 1 kWh, it reduces. Okay, thermal efficiency increases, brake specific consumption decreases. Correct? Both are inversely proportional to each other. And again, with respect to spark timing, that is when we take any alternative fuel, we have to optimize the spark timing. That is also a very important thing. Otherwise, the output power will be less. For example, you can see the petrol and oxygen mixture are taken, and when the spark timing is 10 degree before top dead center, this is the top dead center. The spark timing is one timing, second timing, and third timing. If the spark timing is 10 degree before top dead center, you can observe the combustion is initiated maybe after top dead center. That is, a piston already reached top dead center and it is moving downward direction. So the combustion is happening and it will try to expand. By that time, the piston is moving downward direction and the effective pressure won't we get. So you can observe the combustion will be maybe here, that is during expansion stroke. So the work or the area under this curve will be less compared to other thing. Okay. And the second case, if you, okay, so you take the 50-degree crank angle. That is 50 degree before top dead center. The spark is produced after ignition delay. The combustion is initiated and the pressure rises like this. That is very near to the top dead center. That is close to top dead center means it is a ideal cycle type. But only thing is it drops very fast. Okay. So when it drops, so again when 90% or 60 to 70% of the fuel is burning during compression stroke, so the combustible gas is expanding in opposite direction to the piston movement, and there will be a loss of energy. But when you optimize the engine with respect to this, it's not same for all the engine. It depends on type of the engine, type of the fuel, and we are using. So here, when you produce a spark at 30 degree, after ignition lag, the combustion happens and there will be normal combustion. So when you measure the area under this, it will be better than the cases. So what I want to say is, if you take any alternative fuel, even the spark timing or optimization of spark timing is a very important thing. So if we are not optimizing that, again, in designing a SI engine, this abnormal combustion is again another disadvantage process. So maybe if the engine is not cooled properly or the burning happening at some different conditions, the abnormal combustion happens. That is during the expansion stroke, the combustion will start at multiple places and it will produce abnormal pressure. That is pressure disturbance will be there. It strikes the piston head and cylinder walls or valves and etc. So erosion takes place and engine vibration also will increase. Okay. This is the concept list. This I'll skip. This is the abnormal combustion. This is the once the knocking comes, high pressure wave strikes the surface and the erosion takes place. You can see the shape of the piston head or even edge of the piston, valves, and etc. Erosion happened. This I'll skip. Yeah, I'll move on to the alternative fuel. Why alternative fuel is required, and energy is also very important thing. So the world population is moving towards 9 billion. Presently, we crossed 6 billion all over the world. And with respect to the population, India stands first. That is, we have overtaken the China, and maybe so the population is increasing, and people are moving from rural to urban, and the energy consumption is increasing day by day. So the world population is distributed like this. So you can observe 75% of the world population is located in Asian continent, including China, India, and other specific zones. The rest will be less, and they have a huge area. That is, population density is less in other countries compared to India and China. So with respect to transportation, so maybe nowadays, we know even we transport many things from one place to another place, and the world has become like a village, and maybe because of improved technology in transportation. So maybe through air or through water or through on road, we can transport the goods from one place to another place or one country to another country, and we can see uh, the oil used per day in Asia Pacific or America and other things. So China or India, because of more population, more energy consumption is happening in Asian specific countries. Okay, and you can observe it is increasing day by day. So even whether if we move towards electric vehicles, the electric energy produced from fossil fuel, the trend will remain same, or it may be more. But if we move towards the renewable energy, maybe we can reduce this part. Okay, but in same trend you can observe in all over the world. So this is how energy consumption is happening. Electricity generation, industrial, transportation, residential, and commercial. So again, it is increasing in order. It is in quadrillion BTU. Okay. So with respect to the type of fuel, light duty, heavy duty, heavy marine, and rail. So a lot of research is happening related to this. And with respect to the countries, same information. And again, the same information. You can observe here. So before that, we mainly depends on the fossil fuel like gasoline and diesel or jet fuel. But nowadays, a lot of research is happening related to the ethanol and other fuels. Okay, including the biodiesel, we are working. A lot of literature is available and methodology is available. And with respect to the transportation, uh, even demand is growing, and because of this, carbon dioxide is also emission of carbon dioxide is also increasing day by day, because when we are burning hydrocarbon fuel, whether you go petrol or diesel, again it's made up of hydrocarbon. So LPG, that is propane and butane, CNG is methane. Again, all most of the fuels are hydrocarbon fuel. So when we burn hydrocarbon, carbon dioxide and nitric oxide emissions will be released to atmosphere. There's some data you can refer. Maybe I'll share with Madhu. Same data. So energy consumption by sector. That is same trend is moving. Yeah. Now, as I said, maybe in future we may move to the fuel cells technology, but at presently there are some again some disadvantages are there, and technology is not mature enough to release to the public. Maybe once it get stable research happen, it will be released, and the more other things will take other things will go up, and fuel cell technology will become will dominate. Okay, so at presently, even the government of India is giving importance to the clean fuel, whether with respect to the petrol or diesel or any alternative fuel. So the present government is talking about clean fuel like hydrogen, because hydrogen is a single component, that is a chemical component. After burning, so it will produce only H2O, that is water. So if you operate with a in some fuel fuel range, so NOx emission can be reduced. Okay, so like this. Why advantages when you take anything, whether you take fossil fuels, again it is hydrocarbon, the hydrogen will be present. We can separate carbon and hydrogen, and we can store the hydrogen, because nowadays hydrogen can be produced from methane, that is a CNG gas. So I'm going to tell that technology. So methane reforming method. Hydrogen consists of one atom, and this is the physics of the hydrogen. You can observe, and again it found in a different form on the earth, but compared to petrol or diesel, it is not available very easily. Generally it is accompanied with another chemical element. If you want to separate that another chemical or element, so we need energy. So that energy cost is also included in hydrogen. For example, in school days we studied electrolysis method. That is, use water can be splitted into oxygen and hydrogen. But only thing is we need electricity. So like this. So it is expensive at presently, but nowadays a lot of research is happening related to the renewable energy. That is using a gasification method, we can produce hydrogen, or we can go for liquid to CNG gas, or liquid natural gas. We can convert into hydrogen. Okay, so there are a lot of new technologies are there, and the people are working on that. That is production of hydrogen. Why the developed country or our present government is giving importance to hydrogen is this graph. You can observe natural energy, that is hydrogen is produced. It may be from the CNG gas or petrol, or including water. So after producing hydrogen, maybe oxygen we can store or we can leave it to the atmosphere. But hydrogen can be stored, distributed, and utilized in a ice engine. Okay, that is after burning. So oxygen is taken from the atmosphere or stored thing. Combustion happens. The after sun, it will be H2O. So you will get this one. Again, it is a recyclator. That is, if you take a water, split hydrogen into oxygen, again burn. Only thing is we need some extra energy. Okay, so that is a thing. So when if you see the our present government advertisement or publicity, generally it is given on hydrogen production or hydrogen storage, or including hydrogen utilization. Not only in ICE engine, it can also be used in fuel cell vehicles. So the lot of funding is available with respect to this production or storage or utilization. The government is giving encouragement here. So when we focus on production, there are three popular methods are there. One is a steam reforming method. That is, we can convert CNG gas into hydrogen. Second one is electrolysis of water. That is, a water using electricity and water, we can produce hydrogen. And third one is renewable energy sources. That is, any biomass, including wood or this one, we can convert into hydrogen and carbon monoxide. We can store. But other two methods, again, direct thermal decomposition of water, that is nothing but decomposing H2O into H2 plus O2. We need high thermal energy, maybe around 2500 degree heat we have to supply. So then H2O will be converted into H2 plus O2. But it is again expensive method. And next method is again safety wise. Nuclear energy is there. So, but presently, even India also, the people are working on all these three methods. Even IOCL in Faridabad, they are working on steam methane reforming method, that is converting CNG gas into sun. And in Dwaraka, they opened a hydrogen fuel station, that is a hydrogen plus methane, that is CNG gas. That is generally they say hydrogen fuel. They are using, they are supplying, that is IOCL. And electrolysis of water everywhere, that is throughout India. Hydrogen is produced from the electrolysis of water. At presently, if you buy a hydrogen, even 1 kg, it costs around 2000 rupees. Okay, at presently. But once this steam methane reforming comes, the cost will. But compared to mileage or thermal efficiency, hydrogen fueled engines have a better. Okay, I'll show you at the end. When you take the methane, which is maintained using some catalyst, nickel and aluminum oxide, so that carbon monoxide and hydrogen, and we can supply wherever we want. That is the advantage and disadvantage. So you can observe methane is available, they are produced through pipeline, or we can store and we can supply through transportation, road transportation. This is the method. Steam and CNG gas is supplied. The temperature is maintained and catalysts are maintained. So finally, hydrogen will be produced. Advantage and disadvantage, we can observe. Pipeline system, yes, we can supply hydrogen through pipeline. Most cost efficient current hydrogen process. Finite resources, because CNG gases are available in limited places, and so the plants we have to put here means a limited resource. Rising natural gas price. The final price of the hydrogen also mainly depends on the natural gas. This is the second method, production of hydrogen, electrolysis of water. You can observe water can be produced using hydrogen can be produced using electricity. Okay, so we can observe here. Advantage is free from carbon dioxide, because H2O will be there after producing the sun. It will be only H2. I mean H2 plus O2. Okay, and we can produce hydrogen wherever we want. It's a small system, but it is expensive because we are using electricity. Okay. This I think one slide is missing here. Storage, and I think you might have seen hydrogen cylinders. It's been red cylinder, and it is made up of steel. But again, nowadays for the automobile purpose, the cylinders are materials are changed. So hydrogen can be stored in three ways. Gas, that is in compressed gas, maybe up to 700 bar we can fill in cylinder, and Second method is liquid hydrogen, that is including in India, that is ISRO and Tata Motors. They are working on this because ISRO is expert in liquid nitrogen, liquid hydrogen handling son, and Tata Motors, they are developing fuel cell based vehicles. Maybe in future it will come. Metal hybrid son, as I said, BHU, that is IIT BHU, they are working on this method. The hydrogen can be stored in metal so that at high temperature, hydrogen will be released and supplied to the engine. So this is the first case, and this is the advanced version of hydrogen cylinders. Nowadays, it is available in even Indian context. So we can store up to 400 bar or Type C. I mean, we can up to 700 bar. Okay, liquid hydrogen. But a disadvantage you can observe, when we go for liquid hydrogen, the temperature will be below or to 7. There is cryogenic condition we have to operate. So again, current electricity is involved, and only thing is the energy density, that is a per kg or per volume, is very high compared to the petrol. Okay, but only thing is we have to maintain cryogenic condition. Metal hybrids. So you can observe lithium or sodium dioxide metals are used so that at high temperature, I mean, the hydrogen is stored in metals, and at high temperature it will release and it can be. This is the work I did at IIT Delhi. So this is not only other people, even our former late Dr. Abdul Kalam ji also said, even maybe we have to work towards clean fuel, that is hydrogen. So by 2020, but we have passed 2020, and the government of India is giving importance to the clean fuel. Okay. So when we produce or after transportation, the utilization is very important thing. So not only for the space application, so we can on road also we can use maybe in the form of two methods. One is fuel cell, and second one is internal combustion engines. So you can observe advantages and disadvantages with respect to hydrogen fueled IC engine and fuel cells. The overall efficiency is less, overall efficiency is higher. As earlier I said, when we use hydrogen in a fuel cell, the overall efficiency, that is the thermal efficiency or conversion efficiency, will be higher compared to IC engine. Okay, so more noisy because the combustion is involved. Here only the reaction will be there. Okay, silent one. So maintenance, because moving parts are more, maintenance will be more, and here only the reaction chamber. So like this. So you can see the advantage, I mean disadvantages with respect to fuel cell, advantages with respect to this. Okay. This slide already I shown, but I with respect to the hydrogen, this blue highlights the advantages, and the red properties highlights the disadvantage. So including air displacement, you can observe 29. When you take a 100 cc engine, nearly 30% of volume is filled with hydrogen. Remaining will be air, that is 70%. So it reduces the power output. So there's a disadvantage, but we can improve by adopting the direct injection system, and we will get the better thermal efficiency and including better power output. So this whatever red are there, the properties like stoichiometric or minimum ignition energy or quenching distance, we can convert a disadvantage to advantage by adopting maybe using a new technology like uh, fuel injection system at the right time, right quantity, and ignition system at right quantity at right minimum. So when we use or when we develop IC engine fueled with hydrogen, we are experienced with this type of thing. Or anybody, when you can observe in literature survey, flashback or backfire, pre-ignition problem, or rate of pressure rise. So maybe flashback or backfire occurs due to the minimum ignition energy will be present in the valves or the cylinder, or the residual gases will be present. So it carries some energy, that is a heat energy, that will be added to the hydrogen air mixture. The combustion starts maybe during section stroke, or during compression stroke, start of compression stroke, or once the combustion happens, the rate of pressure rise will be very high. Okay, so we can disadvantages using or by developing proper fuel injection system. Okay, so the hydrogen can be used as an engine, the engine, but only thing is only few percentage of hydrogen used in sun. But in SI engine, we can completely we can replace, or partially we can replace gasoline or CNG. And these things already I told you in the beginning. Carburation system, injection system. Presently, people are working on direct injection system, including hydrogen or CNG gas. Fuel can be injected directly into the cylinder, just like a this one, diesel engine. Okay. So this data I've taken from the web. So many automobile manufacturers, they're working on hydrogen operated engines, and these are the vehicles, but it's not on road, and few are on road, and few are within the campus. And this is the vehicle developed at IIT Delhi, and so IIT Delhi, Mahindra were involved in this. So engine was optimized using the hydrogen, and it was giving very good power output. So when with respect to the performance of the engine, so that is generally what we see is what is the power output, what is the thermal efficiency, whether what are the emissions and other thing. So after identifying the alternative fuel, the testing is done, and setup is not there, just remove. So you can observe the brake power is with respect to hydrogen is less. As I said, we operated with a linear mixture, or less than the zero 0.6 equivalence ratio. The power output will be less compared to hydrogen. Okay, don't worry about this. It's a single cylinder engine. And even, but the thermal efficiency is increased. That is a power output by energy input. So you can observe it is giving better thermal efficiency compared to the petrol. So it is inversely proportional to thermal efficiency. Okay, less fuel consumption with respect to petrol. But another disadvantage of this hydrogen engine is volumetric efficiency. As I said, the density of the fuel is 0.08 kg per meter cube. And when last slide you have seen 30, when you take 100 cc of volume cylinder, 30% filled with hydrogen and 70% air. And what I want to say is the volumetric efficiency is less because of less density of hydrogen. Yes. So next, the disadvantage, you can see the x-axis, the equivalence ratio changes from 0.4 to 1 point is gradually emission will be there. But nowadays, as I said, SCR devices are available. That is a selective catalyst reactor. We can more place in the exhaust gas or tile pipe, so that NOx can be reduced. Okay, so this is the summary of this one. Okay, with respect to the production. So with respect to the development of the engine, an appropriate design manifold injection system or direct injection system, undesirable combustion phenomena can be reduced. So this is the last slide. So what I want to say is hydrogen will be the future fuel, and it will be the perfect fuel for the more populated country like us, because even we have seen Delhi when October, November, December comes, always population, pollution problem will be there. That can be avoided, or we can minimize. I'm not saying that 100% remove. It can be minimized using hydrogen as a fuel in metro cities or wherever population is more is there. Okay. Thank you. So
Dear
now I
friend-
request
dear friend,
if you have any specific queries, open for discussion.
So good evening, sir.
Good evening.
So very nice to see you. So
Thank you.
it was a very excellent and nice presentation, and you have shared your
Yes.
experiences in the field of IC engines as well as with hydrogen as a fuel. So great contribution to the
Thank you.
knowledge. Meanwhile, I also visited your lab in the month of May 2024 during MBA visit.
Okay. No, Dr. Chitragar was there during that time. He is one of the participants.
Maybe I am Dr. S.N. Sapli
Yes.
from COE Pune, College of Engineering Pune.
Okay. Nice meeting you, sir.
Nice actually. You have shared that knowledge related to hydrogen, no? So that is
Yes.
fantastic. Value addition to the attenders.
Yes.
So one small doubt I have, with all
Yeah,
the
please.
parameters being optimized in petrol engines,
Yeah.
what is the maximum compression ratio one can achieve
See, presently we
or achieve?
see, for example, petrol compression rate. Petrol operated engine, maybe nine compression ratio. With respect to hydrogen, we can go up to 12 or more than that. Only thing is, as I said, we are right now we are working with maybe timed manifold injection system. But once direct injection system comes, we may we can go for air compression ratio also. By checking the knocking system or also.
Okay. Thank you. Thank you
Yeah.
so much.
Thank you.
Good
I hope
evening, sir.
many research scholars are there.
Hello.
Hello, sir.
Yes. Pravinji.
Yes, sir. Good evening, sir.
Good
This is
evening.
myself, Dr. Praveen Mitnare from D.Y. Patil College of Engineering Mechanical Department.
Okay.
Sir, my one question that while using the hydrogen in SI engine,
Okay.
the spark timing approximately we have to give it up to TDC.
No, not
because
TDC
because
means
of its high
no.
ignition energy and it's
Correct.
So optimum up to how much we can make it the spark timing limit.
See, whenever you take any alternative fuel, for example, you are changing the compression. You are taking petrol engine, and now you are changing the compression ratio. You cannot use same timing. That is spark timing.
Yes, we'll have to
You have to
retard it.
optimize.
Yes,
When you
little.
optimize, you can go on changing the timings like maybe 5 degree before TDC or 8 degree, 10 degree. When you change the timing, you have to check the torque, how
Torque.
torque is changing.
Yes,
So
MBT,
once
MBT
it
time.
comes a maximum, maybe we can stop this one.
Okay. Means depending on the power and the condition, we'll have to check it at the what will be the MBT at that condition, right? At that power.
Yes. Because even as earlier I pointed out, the minimum ignition energy depends on even fuel ratios. If
Yes,
the fuel ratio is very lean, so we may have to supply more energy compared to stoichiometric condition.
right. And one simple question which I want to ask is comparing with the electric vehicle and the petrol vehicle. though we called it as a electric vehicle zero emission, but comparing if we are running for the 100 km with the electric vehicle, whatever the emissions which we are going to, or whatever the power we are going to utilize, that same power for generating that same power, I think that the emissions which are going to produce while producing that power at the power station, isn't that is a less or the more?
More only, because as I said, when power is produced at power plants, it is away from the city. Okay, so
Yeah.
the electric losses will be there.
Yes,
If you are using one unit here, one unit will be lost will be there.
loss, transmission loss.
Yeah. So if you produce 2 units, when more amount of emission will be added.
Means we can't call it as a zero emission. So isn't it will be future of the vehicle? Future vehicle of our
Future,
India.
at presently, see, even government, I mean, they are working on this. The battery is also, again, after 5 years, it will create problem in future.
Yes,
How
yes,
to dispose the batteries? Because at presently, the lithium batteries we are importing from other countries, maybe China or Taiwan. So how to dispose, that will be a future problem
yes,
in coming days. Yeah.
yes, yes,
So maybe in future solution will may come.
yes, sir.
Yeah.
Thank you, sir. Thank you very much. And very nice session, sir. You had given very nice,
Yeah.
enlightened, very nice knowledge about the IC engine and the fuel cell and the electric vehicle. Thank you, sir. Thank you very much.
Welcome.
Hello, sir.
Yeah. Tabish.
Hello.
Tabish, how
Hi,
are
yes,
you?
sir. Hello. Yeah, I'm good. I'm good. How are you, sir?
I'm fine. Yeah. Please.
It's okay. Just a thing, but actually, I started doing some research on it. I take
Mm,
some overview and your ideas.
mm,
We are thinking to move on from lithium-ion battery to hydrogen cells. So some
mm.
of my clients are started working on it and thinking to get some overview how efficient that hydrogen cell will be over lithium-ion battery cell. So just wanted to know, is it, how do you compare the hydrogen cell battery in future over lithium cells and battery? What will be the future of? I know the lithium ion cell battery that you are talking about. The dispose of this will be a huge thing, and is no way is no zero emission technology is not at all is there that we come to know
Yeah.
that just as a myth. Okay, but what do you think about the hydrogen cell technology?
Now, hydrogen fuel technology. See, in European country, most of the universities they are working on this area. But with respect to Indian context, the hydrogen production itself is a problem because the technology we are. I mean, even though the technology is available, the government is not investing on that. So maybe in future, in European country or American countries, they will come with this fuel cell technology, that is hydrogen fuel cell technology. That will overtake all the this transportation vehicles. That is fuel.
So
For
what will be the major reason? What is the major what is the major specification or feature of hydrogen cell that will overcome lithium ion battery?
specification means the overall thermal efficiency will be better. Okay, that is the one. This one. When you compare maybe thermal efficiency of IC engine is 35 to 40, that will be more than 45 to 50, like that.
Okay.
If
So
you
in that
refer any papers, the overall
thermal
efficiency will
efficiency
be
and
better.
thermal
Yes,
efficiency point of
I mean
VT
mileage. Finally, if you say
range.
vehicle, it's a range mileage. Okay.
Mhm. Thank you, sir.
Well,
Nice, sir. By the way, it's a nice lecture. It's an informative one, sir, for all of us.
thank you.
Thank you, sir.
After a long time, we are saying.
Yeah,
Yeah.
thank you, sir.
Dear participants, if you have any questions or the queries, please ask to speak, sir.
Hello. Yeah, good
Yeah,
evening, sir.
Chitra. Good evening.
Yeah, Kumar sir and Supply sir, and all the
Yeah.
participants. Just before my question, I would like to say support Dr. Kumar GN, who is a eminent speaker of today's second session. In fact, I'm very proud to say that I'm a sir student in NITK Surathkal has worked under him. Really, he's a true mentor, guide, a friend, whatnot. Really, it was. I would like to say I'm very lucky to work under him, and I wish that everyone should get a guide like Kumar sir.
Not like that. All are good. Only I got all good students, including you.
Thank you, sir. Thanks. That is,
Yeah.
you are good. Sir, just wanted to ask one question on this thing. Like, you had summed up the use of hydrogen in a engine, and it was, before that, I would like to say the session was very informative and really it was started with basics of IC engine starting from 150 years ago and then reached up to the advanced technology as in today. What is happening on the road, like from invention of a petrol to the use of this hydrogen in India. It was really very nice talk, sir. Informative session for all of us. Thanks for that purpose. And even I'll thank sir also. Sir as one of the MTech evaluator for my project. Supply sir, thank you for that also. I'm very happy to see both of you on a single platform. Even I'm very happy
Thank you
to
very
see.
much.
Thank you, sir.
Okay.
Thank you.
Okay.
And to see on this online platform for so long days, sir. Kumar, sir.
Oh, Anil is
Coming,
also there.
yeah, sir. Thank you. Coming to my
Anil,
question, like,
yeah.
sir.
Please,
Yeah.
continue.
Coming to my question, like, sir, what is the status of use of this hydrogen in particularly CI engines as of now? Compression ignition
No,
engine.
as I said, now government is giving importance to the green fuel, and even the automobile manufacturers, including the fuel manufacturers, IOCL, and many people are working on this one. Maybe in future, maybe within 5-6 years, the hydrogen will be considered as the auto fuel, similar to maybe biodiesel. Hydrogen will be added in CNG and maybe in small percentage, 5 to 10%, so that hydrogen will be introduced. Maybe in coming days, maybe within 5 years, it will come because most of the automobile companies they are investing money on this.
Yeah, definitely. So in the injection mode, so this hydrogen will appear in I- engine like diesel engine.
Yeah, the development of injector, it's nowadays happening
Is
because
required.
if you
Is
refer
required.
literature survey,
Yeah.
theoretically a lot of papers are available. Manufacturing, I mean, most of them are all on patented. So information is not available on open literature.
Yes, sir. You are true, sir. You are true.
Yeah.
Yeah.
Sir, the next question is like we have, I mean, India is focusing about the ethanol, biodiesel as well as gaseous fuels. So that is CNG and hydrogen. But then looking into the production of these LC vehicles as an how far it is, I mean, worth to work, yeah, take the students to work on the diesel engines for the, I mean, future of them as well as for the nation, sir.
See, again, both are whether petrol or so on, all are hydrocarbon only. Only thing is the government is giving importance to smart cities. So with respect to smart cities, I mean, if, maximum cities, if they adopt a smart city method, the pollution will be less because the school, colleges are, I mean, they're trying to adopt IoT, I mean, internet-based this one. So the emission, I mean, they wanted to reduce the energy consumption on road or transportation by adopting the smart cities. Okay, so maybe you have to wait and see how people will be cooperating.
Okay, okay, sir. Thank you.
Welcome.
And I would like to thank Madhu also for making me to meet with all my NITK friends like Tabish, Anil.
And
Yeah, everyone. Thank
Good
you,
evening,
everyone.
sir.
Yeah, thank you,
yeah,
Kumar,
good
sir.
evening. Yeah,
Yes, sir.
Anil.
Before somebody asks questions, sir, I would like to greet you.
Yeah, please.
Sir, I would like to greet you. Good evening, sir.
Yeah, good evening. Good evening. How are you? Yeah.
Yes, sir, I'm good, sir. Initial part I missed it. Joined bit late.
Okay. If you have a question, I can ask. Otherwise, if some people are asking, I'll come back to you, Anil.
Okay, sir. Okay, sir. Okay, sir.
No, some people are raising. I don't want to
Yes, sir.
take
Yes.
their time.
Yes, sir. Yes, sir. Yes, sir.
Participants, if you have questions, please you can ask to this. I think, sir, no questions from the other participants. Anil, sir, you can ask the questions, sir, if you have questions.
Yeah, Anil, now you can take over.
No, sir. Simply I saw you. I was so happy to see you.
Thank you. I'll call you after
Yes,
this
sir. Yes,
session.
sir.
I'll call you.
Yes, sir. Yes, sir. Definitely, sir. Sir. Thank you.
Thank you very much, sir. In spite of busy schedule, Dr. Kumar Jain, sir, he is not handling only the academic as well as the administrative. So when I was a student of the NIT Surathkal, he used to be busy almost from morning to evening. So if students wants to meet somewhere, like we should take the appointment, like he'll be that much of busy. In spite of all this busy schedule, sir, we accepted our request, and you delivered the session on the this clean energy, clean fuel, sir, which is whatever the session you have delivered, sir. It was from basic to the advanced, even not only from the mechanical department. We have the all the participants from the different branches. They also got to know the detailing about the this IC engine, because people they are like sometimes they say that engines are not giving the efficiency, everything. So whatever you have delivered the lectures regarding like supercharger, turbocharger, yeah, reduction of the emission or the efficiency, how we can increase the efficiency even as a driver, because we all are using the four-wheelers or two-wheelers every day. So if we utilize these things, whatever you have taught us today, so definitely instead of going advanced itself, we can reduce the carbon footprint. We can reduce the energy consumption. Also, sir has nicely overlooked the regarding the swirling and regarding the hydrogen fuel, how the production happens, and what are the norms and what are the storages we should have for the hydrogen. And sir, really, it was really informative, sir. With this, all the whatever the knowledge you have percolated to us, definitely all the participants they will utilize for their further research as well as the future growth, sir. Once again, I will thank to Dr. Kumar Jain, sir. Thank you very much, sir.
Yeah, thank you, brother. Thank you. I thank all of you for listening my talk. If anything is there, you can write mail to me. Whatever I know, I'll share my information. Thank you, one and all.
Thank you very much, sir.
Yeah, Chitagar, I'll call you back.
Yeah, fine, sir. No issues. Thank you.
Yes.
So have a nice time. Bye.
Yes.
Nice day.
Thank you,
Have
sir.
a nice day. Thank you, sir.
Yes. Dear participants, it is time to end the today's second session. So we had the very informative sessions, first and second sessions. So I would like to thank all the participants because we used to deliver the lecture for 1 hour, but we used means we are not supposed to, or will be not interested to have the 3 years lecture continuously. So today means every day we are having the 3 hours sessions. So patiently we are listening the sessions, which will really helpful for all the academic and the industry fraternity. Thank you all the participants. So again, the tomorrow schedule, which will start at the 6 p.m. to 7:30 and 7:30 to 9 p.m. I request all the participants, please join before 6 p.m. so that we can start the sessions on a regular time. And those who have not given the feedbacks, please give the feedback, and also try to, even some of the participants, they have we connected to the Google Meet with a different ID or with a different name, so which will be little bit difficult to us to monitor your attendance also. So kindly you can log in with your registered name and the surname, which will more helpful for organizing team. Thank you one and all.
Hello, sir.
Yes, sir.
Can we get the details about the presentation, and are you sharing later on, or when you are going to share?
Sir, later we will share. We'll take all the presentations from the experts, and we will share to the group, sir.
Okay. And where to give the feedback? Yesterday we have not.
Sir, today I have shared the feedback link to the WhatsApp.
Okay. Have you shared the link?
Yes, sir. Yes, sir. I have shared the link to the WhatsApp. Just to go through the WhatsApp, sir, you can give the feedback. And for today's session, we'll again post the feedback by tomorrow morning, so that you can give the feedback, sir.
Okay, sir. Okay. Thank you. Thank you.
Thank you very much. Good night, all participants.
Thank you, sir.